Now that we've talked about both fractions and decimals, the last thing we're going to talk about here is converting between them. So of course, when we have decimals, there are all different types of decimals. If you have a irrational number, something like the number pi, then that decimal actually goes on infinitely. So pi is 3.141592653589979, and it keeps going forever and ever and ever. Sorry, that's as far as I remember. But there's no pattern to it, and there's no repeating part here, and it will never terminate, it will never stop. But that's an irrational number, right? There are other irrational numbers like E, which you may have seen if you took Math 112, which is like 2.71, and again, that keeps going forever. Or some square roots, if they're prime numbers, especially square root of 2, square root of 5, those will give you irrational numbers. But irrational numbers can't be written as a fraction. So since we're talking about converting between fractions and decimals, fractions are rational numbers. So a rational number is any number that can be written as a fraction. And pi and e and square root of 2, those things can't technically be written as fractions, so those are not considered rational numbers. If something can be written as a fraction, then when you convert it to a decimal, it is either going to terminate or repeat, right? So if you get something that doesn't terminate, doesn't stop, and it doesn't repeat, like pi, it's not a rational number. It can't be written as a fraction. But for any fraction, this should happen. So if we want to convert any fraction to a decimal, that decimal should end up either being terminating or repeating. Terminating, of course, just means that it ends, right? There's a finite number of non-zero digits, right? And then repeating means that it goes forever, but you're going to notice a pattern of repeating digits. So for example, we can see this number 1.527272727, and you can see the ellipses, which are the dot 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 there. Make sure you always include those if you don't include a repeat bar to indicate that it's going to keep going. And so the better way, of course, would be to use a repeat bar. So what we would do here is the part that's repeating, we would put a bar over it to indicate that. So the correct way to show this one would be 1.527 repeating, and there's not any better way to say that. So you wouldn't say that, like we've emphasized before, like if you had something like this decimal, that you should say that as 1 and 527 thousandths. But if you've got a repeat bar over it, you wouldn't say it that way. You wouldn't say it as 1 and 527 thousandths repeating. You would just say 1.527 repeating. And unfortunately, there's not really any way when you're saying it to indicate anything different in terms of which part is repeating. So for example, in this one, the 2 and the 7 are repeating, and I would read that as 1.527 repeating. But if only the 7 were repeating, I would still read it the same way, 1.527 repeating. If all 5, 2, and 7 were repeating, I would still read it the same way, 1.527 repeating. So like if you ever need to do an accommodation, let's say for a blind student or a student that has vision problems, you would actually need to say out loud, like, this is the part that has the repeat bar. So in this case, the 2 and the 7 have the repeat bar over them. And so there's some incorrect ways here that I've listed. So keep in mind that whenever you do this, you want to write the fewest number of digits necessary, and you want to only have the repeat bar over the part that repeats, and you don't want to have it longer than it needs to be. So like notice on this one, the 2 and the 7 and the 2 all have the repeat bar on them, but that last 2, I've already got it, right? So I've already got a 2 underneath my repeat bar, so it's extra to list that last one. So that would be incorrect there. And then here, 5.272, even though if you continued that, you'd get the same number, we really don't want to write any more digits than we need to. So I've already written this 2, I don't want to write it again, right? So this is the correct way, 1.527 with a repeat bar over the 2 and the 7. So what we're going to do here is we're just going to practice converting between these two. So we're going to just start with what we've kind of already done a little bit. Start with decimals and converting them into fractions, and then we'll go the other direction. We'll convert fractions into decimals. So what we've talked about before is that when we have a number as a decimal, we can really easily convert that to a fraction just by taking all the digits in the number and putting them over the last place value. So in this case, my 3 is in the 10th place, 6 is in the 100th place, and 2 is in the 1000th place. So my last place value is the 1000th place, so I place this over 1,000. You could also do this as 8 and 362 thousandths, the way that we say it, but then you'd have to do 8 times 1,000 plus 362 to convert it to an improper fraction, and really I don't need to do that extra step. I can just quickly write all the digits in my number as my numerator and then put it over 1,000. And then essentially you've done what you were asked to do. At this point, we have taken this decimal and rewritten it as a fraction. The last bit would just be, do you get it simplified, right? So just simplifying that fraction. Now, the nice thing here is that if you started out as a decimal, then that means that when you write it as a fraction, your denominator is going to be 10 or 100 or 1,000 or 10,000 or some power of 10, right? And so if you take, like, for instance, this one, the number 1,000, if I were to break it down with a factor tree, that might be, for example, 100 times 10, and then 10 is 2 times 5, and 2 and 5 are prime. 100 breaks down to 10 times 10, but then each of those 10s breaks down to 2 times 5, and 2 and 5 are both prime numbers. And it doesn't matter, like if I had 10,000, then I would have broken it down to 1,000 times 10, and that 10 would have broken down to 2 and 5. So my point here is that since you started as a decimal, the denominator is a power of 10, which means when you break it down, it breaks down to all 2s and 5s, right? When you break it down to its prime factors, the prime factors are never going to be any other prime numbers besides 2s and 5s, which means these are really easy to simplify because you only have to check, will 2 go into both the numerator and denominator, and will 5 go into both the numerator and denominator? Now, sometimes it might go in more than once. So like, I'm noticing on this one that I could divide both the top and the bottom here by 2, but I might need to check that again. Maybe 2 goes in another time, right? So you would keep checking 2 and 5, but once you've checked 2 and 5 and realized that it doesn't simplify any further, you're done. And then 1,000 divided by 2 would be 500. And then let's see, 8,362. I'm just gonna use some mental math here, and you can do that how you like. Dividing by 2 is just taking half of it. So half of 8,000 is 4,000, half of 300 is 150, half of 60 is 30, and half of 2 is 1. So I'm just gonna add all that up to get 4,181. That's just my method of mental math. You can do that however you like. So I get 4,181, and then I would keep checking this, but again, I only have to check 2s and 5s because it started as a decimal. So I can see that 2 would go into the denominator, but it wouldn't go into the numerator because the numerator is not even. 5 would also go into the denominator because it ends in a 5 or a 0, but the numerator doesn't end in a 5 or a 0. So that means 5 won't work, which means this is my simplified fraction. So I'm going to do one more example of this. So the quick way is to take all the digits in your number, and in this case, I don't really need to write that 0 in front of the 6, so I'm just going to leave it off. And then put that over the last place value. In this case, this goes out to the tenths, hundredths, thousandths, 10,000ths, 100,000ths place. So I would put this over 100,000. And then you've basically done it. It's just down to the part of simplifying this. I can already tell that 2 is not going to work here because this is odd, right? It ends in a 5, so 2 won't go into that evenly, which means the only other thing I have to check is 5. And I think that will work, right? Because if they end in a 0 or 5, then it's divisible by 5 using those divisibility tests that we learned in MAE 201. Let's see. So if I take 100,000 divided by 5, that should be 20,000. And then I'm just going to go off to the side and do some, I'm going to choose long division here to do the 6,095 divided by 5. I don't have a I don't have a quick mental math way for that, so I'll just do it this way. So let's see, 5 goes into 6 once, 1 times 5 is 5, subtract, I get 1, and I'm gonna bring everything else down. 5 won't go into 1, but it goes into 10 2 times. 2 times 5 is 10, so 10 minus 10 is 0. I have a remainder of 0, but I'm not done because there's more to bring down. So I'm gonna bring down the rest. 5 will go into 9 once, 1 times 5 is 5. Subtract 9 minus 5, I get 4, bring the rest down. 5 goes into 45 9 times. 9 times 5 is 45. So that gives me a remainder of 0, and this is 1,219. Again, check and see, will 2 or 5 go again into either the numerator or the denominator evenly? Since the numerator ends in a 9, I know that neither a 2 nor a 5 would go into that. So that's my answer.